Alright, today we're working on section 2.4, which is the chain rule of differentiation. So this is used when we have a function inside of a function, or the composition of functions, f of g of x. And the way that we take the derivative is we multiply, this is probably the easier definition to understand. If we have a function f of g of x, we take the derivative of the outside, leaving the inside alone, times the derivative of the inside. And we notice that we use this when there's a function raised to an exponent or a function inside of a function. So anytime we see that, we need to use the chain rule. I'll leave that up. So for now, we have y equals x squared plus 1 all raised to the third power. So take the derivative of the outside. In this case, the outside is the cubing of the whole function. So we bring that down, 3, leave the inside alone, and the power rule tells us to lower the exponent, so we have to do that next. And we have to multiply it by the derivative of the inside. The derivative of x squared plus 1 is 2x. And then obviously we're going to multiply the outsides together if we can, which is 6x times x squared plus 1 squared. Okay, so the general power rule, which is what we just used, if we have a whole function, u of x raised to the nth power, we bring down the nth power, leave the u of x on the inside alone, lowering the power on the outside, multiplied by the derivative of the inside. A simpler way without the x's to say this is n times u to the n minus 1 times u prime. Okay, so we're going to find the derivative of 3x minus 2x squared all raised to the third power. So our inside is 3x minus 2x squared. So just have to remember to bring down the 3, leave the inside alone, lower the outside, times the derivative of the inside, which is 3 minus 4x. Now you can distribute that 3 into the 3 minus 4x if you so choose, but this is actually okay. Find all points for which this derivative, the f prime equals 0, and those when f prime does not exist. So first we have to find x prime. So instead of using the cubed root, I'm going to rewrite this with an exponent. Okay, this whole thing is raised to the 1/3 power. Now this would be a chain rule inside of a chain rule if we didn't notice that we could combine those two exponents to make this x squared minus 1 to the 2/3, because 2 times 1/3. 2 raised to the 1/3 is the same thing as 2 times 1/3, which is 2/3. So now we can do the chain rule, bring down the 2/3 times x squared minus 1 to the negative 1/3 times the derivative of the inside, which is 2x. So 4x over 3 times the cube root on the bottom, x squared minus 1. Now the question is asking us where f prime of x is equal to 0 and where f prime of x does not exist. F prime of x is equal to 0 when x is equal to 0, because we have a rational function, we can tell that by setting the top equal to 0. And we're going to be able to tell when the bottom is equal to 0, which means the function doesn't exist, when x is plus or minus 1. And you could also graph this to find the same answers. Differentiating quotients with constant numerators. So that means there's a number on the top. When that happens, I mean, this looks like a quotient rule. You could certainly do the quotient rule, but it's not going to be very much fun. What I would recommend doing is recognizing that if we bring the exponent that's on the bottom, we can bring that to the top, make it negative. And then it's just a chain rule with a number on the outside. Much easier. So that the negative 7 stays out and outside, we're going to bring down the exponent, lower the exponent to negative 3 times the derivative of the inside, which is 2. And then we have 3 constants now, which we can combine, which turns into 28 times 2t minus 3 to the negative 3, or 28 over 2t minus 3 cubed. Now you could certainly find this by doing the quotient rule, but this was a much easier alternative. Okay, simplifying by factoring out the least powers. So we have x squared times the square root of 1 minus x squared. This is going to be the product rule because we have two functions, x squared is one and the square root of 1 minus x squared is the other. So derivative f prime f times g prime. You're going to leave g f alone. You're going to multiply by the derivative of g, which is 1/2 1 minus x squared to the negative 1/2 times negative 2x plus leave g alone, 1 minus x squared to the 1/2 times the derivative of f, which is 2x. Okay, let's see if we can combine everything. So we have negative 2x times 1/2 times x squared, which becomes negative x cubed times 1 minus x squared to the negative 1/2 plus 2x 1 minus x squared to the 1/2. Now I was saying that this here is acceptable. Okay with that answer right there, but the purpose of this problem is to show you how to simplify it by factoring out the least powers. So what we're going to do is factor out 1 minus x squared to the negative 1/2. And since they both have an x in common, we're going to take out an x as well. So when we take that out of the first term, we have negative x squared left. And if we pull out the 1 minus x squared to the negative 1/2, that's all we have left is negative x squared. And on the next term, we have a 2 left and 1 minus x squared. Because if we divided out a negative 1/2, we're just going to have a 1 left. This is the factoring stage. Okay, then we could combine this a little tiny bit. And that would be our final answer. Okay, simplifying the derivative of a quotient. So I'm just going to rewrite this with an exponent instead of a radical. And we could bring that x squared plus 4 to the 1/3 up top, but this is just going to be just as easy to be the quotient rule. So that's what we're going to do. So f g 1/3 times the derivative of f, which is 1, minus f times the derivative of g, which is the chain rule. Okay, we need to simplify. Factoring out that least powers, which is negative 2/3. And what we have left is 3 x squared plus 4 minus 2x squared x squared plus 4 to the 2/3. So we just took that negative 2/3 out of the top and the 1/3. And our final answer, x squared plus 12 over 3 times x squared plus 4 to the 4/3. So what we did was brought what we pulled out, the 1/3 x squared plus 4, the negative 2/3, down to the bottom and distributed through the top to get that answer. Simplifying the derivative of a power. Okay, so we have a chain rule. We have a whole function raised to the squared, second power. We're going to do the chain rule to simplify. So we have to bring down the 2, leave the inside alone. times the derivative of the inside, which is the quotient rule. G f prime minus f g prime over g squared. Multiply through. And this step here, I have simplified the top of our quotient rule to get 3x squared minus 9 minus 6x squared plus 2x. I just multiplied everything through, and then the x squared plus 3 on the bottom just makes it the third power on the bottom. And the last thing I'm going to do, we do not have to multiply through everything. I'm just going to simplify inside of our parentheses. And that'll be good. All right, applying the chain rule to trig functions. So here we do have an inside function, and the inside function here is 2x. Generally, the sine function is just sine of x. So if you have anything connected to your x, you know that that's going to have to be the chain rule. So to take the derivative, we take the derivative of the outside, which is cosine, leaving the inside alone, which was our 2x, and then multiply by the derivative of the inside. Since our inside is 2x, we're multiplying just by 2. 2 cosine 2x. Same thing with part B, except our inside this time is x minus 1, so it's a little bit easier to see our inside. Derivative of the outside is sine, we're leaving the inside alone, times the derivative of the inside, which is actually just 1. So we're done right there. Part C, let's put a 3 before our x because it wouldn't be the chain rule if we didn't have a number there. Take the derivative. Derivative of the outside, leaving the inside alone, times the derivative of the inside. So 3 secant squared 3x. Okay, when we have parentheses, we just need to be really careful where we're distributing and where the chain rule applies. So in part A, this is implied that we have parentheses around the 3x squared. So if we take the derivative, then we need to make sure that we know that that's our inside function. So we take the derivative of the outside, it's just negative sine 3x squared times the derivative of our inside, which is where we made our parentheses, which is 6x. Okay, part B, cosine of 3, if you type it into your calculator, is actually just a number. So this is just saying cosine of 3, which is our constant, times x squared. So this isn't the chain rule at all. You just need to make sure that you're careful not to take the derivative of cosine 3 because it's just a number. And then times the derivative of x squared, which is 2x. All right, part C. Before we take the derivative of this, we need to actually square our 3x because we need our parentheses to be around that whole thing. So that turns out to be cosine of 9x squared, and then we can take the derivative. Derivative of the outside is negative sine, leave the inside alone, times the derivative of the inside. And there we go. Cosine squared, when we have the function that's squared and not just the x, that means that this whole function is squared. That means the exact same thing. So if we're going to take the derivative of this, bring down the 2, leave the inside alone, times the derivative of the inside, which is negative sine. And the last one, square root of cosine of x is the same thing as cosine x to the 1/2. So it's almost exactly like d. I prime equals 1/2 cosine x to the negative 1/2 negative sine x. So simplified negative sine x over 2 times the square root of cosine x. Okay, here's an example of a repeated application of the chain rule. That just means that we have to do it more than once in the same problem. So this function can be rewritten as sine 4t, the whole thing cubed. So notice that you have the sine 4t raised to the third power, which is the chain rule, and then we have 4t connected to our sine, which is another chain rule. So take the derivative, we bring the 3 down, leave the inside alone, lower the exponent, times the derivative of the inside. Derivative of the inside is cosine 4t, and that 4t is left alone until we have to multiply by the derivative of the inside, so you have another 4. So this would be our final answer. Okay, our last question. Find the tangent line of a trig function. Find an equation of the tangent line to the graph of 2 sine x plus cosine 2x at the point pi 1. Then determine all values of x in the interval from 0 to 2 pi at which the graph of f has a horizontal tangent. So our first goal here is to find the derivative, because we need to find the tangent line. So take the derivative of f, 2 cosine x plus negative sine 2x times 2, that's the chain rule, and we want to know what the equation of the tangent line is at pi 1. So we put in pi into our derivative, and we get negative 2. So the equation is y minus 1 equals negative 2 times x minus pi, which I'm okay with you leaving it like that because all of the calculus is done so far. Now we're trying to see where we have horizontal tangents. So we want to know now when f prime of x is equal to 0, because that would give us our horizontal tangents. And if we graph that, that occurs at pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. And there's your homework. That was section 4.